All right, physics people, let's see if this works. So here's what you're going to need to do. You're going to need to use a video I used, or you can upload your own, depending, however much time you want to spend on this. You need to have Logger Pro. And what you first need to do is make a movie. Now, what I did was, so we want to insert a movie. What I did was make a movie of Lightning McQueen toy going on a sort of scale right here. All right. So you can make a movie like this. Let me just show you what it was before we get really into this. So if I play this, Lightning McQueen will come over here, unfortunately. And as you can see, he's driving. It's not a straight line. It's pretty good, though. And on that scale, on that thing he's driving on, if we move it up here, these are each 1 inch. So you can measure how many inches he goes every time. All right, so that's what we're going to do. So you set this up so that it fits on the graph, and something like that ish, I think, will work. All right. And then, like I said, you can just use mine. So the way I did that, I just said insert and I went to movie, right? And then I picked the movie and now it's here. All right. And then what you want to do is right click the movie and say movie options. You want to, I recorded this movie on my iPhone, and my iPhone records slow motion in 240 frames per second. So I need to change the frames per second to 240. And then we want to make it go about 5 to 10. Let's just do 10. You don't need to make this longer than it needs to be. All right. So this will advance at 10 frames every time we hit a button. That's why we did this. So you'll see what that does here. But this will tell you this is telling the computer how many frames per second there is, so it can tell how many seconds are going by. And then this is going to advance the movie 10 frames every time we click a button. So we're going to say okay. And then what we want to do is start Lightning McQueen when he's on the origin. So he's on the origin here. And basically what's going to happen is it's going to advance a certain amount every time we hit a button. So it'll advance from here to here or here to here. All right. So that's what I said, 10 frames instead of what it was, 1 frame. So by going up 10 frames, we're not going to have to wait forever for him to get across this thing, because that would be about 1 frame. This is, anyway, you'll see what happens. All right. So you need to line up Lightning McQueen right here at the beginning. Okay. And the point of this is you need to choose a point on Lightning McQueen that you're going to follow. So it might be this, it might be his rusties, it might be his eyeball. Whatever point you're going to follow along is what you want to start on this origin. So I'm going to follow, I guess I'm going to follow that rusties. So I want to start the rusties on the origin. So the origin's right here, and now that rusties is about on that origin. All right. And then what I want to do is set my, hold on a second. Cancel that. I want to set my distance, and that is somewhere here. Let me see where I can do that. Somewhere I can make the things appear. Movie options. Nope, that's not helpful. Sorry, I did have this. Just as there's a set insert. What if I right click this? Nope, that's not going to help. Nope. All right, so send to back. That's going to be helpful, the send to back thing. What does this do? That's what I need. All right, so now what I need to do is set my scale. So what we're going to do is click on that, and then I know that 12 inches starts here. Where's 0? That's 1. So yeah, I guess that's 0. So this is 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then that's 12 inches right there. So what I'm telling the computer is that is 12 inches. So I got to let it know that that's 12 inches. That's not a, 12 inches. Okay, so what I did there is I hit this meter stick here, which happened when I hit the button here. I got to see all these. And then I went from the origin of my ruler all the way to 12 inches, and I let it know that that's 12 inches. Now, on your screen, I'm sure that's not 12 inches. On my screen, it's about 2. But it's letting the computer know that for every 2 inches, that means the car traveled 12 inches. All right, so then what we want to do is click this thing here, which is the add a point. And we do that, and we add a point right at the origin. So I'm going to use sort of the top end of this Rust-eze because that's about on the origin, and I'll click it. And then what's going to happen is my frame is going to jump to the next. So that's 10 frames forward. And as you can see there, there's a blue dot there now. And I want to do the exact same point on the car that I did before and click it. And now go to the exact same point on the car that I did before and click it. So what this is doing now is keeping track of the distance and the time he's traveling, which is a kind of cool thing that this program does. And I'm losing my point, but I think it's about there. And then it's about there. And then it's about there. Now, unfortunately, this went backwards and now it's off screen. So we're done. All right. Now what I want to do is send this to back. So send to back so I can look at my graph. And here's my graph. Now you'll notice it did 2 things. It did it took the time. So it figured out the time based on the frames per second that I told it. And then it put these dots here. Now, unfortunately, it put a lot of dots that may or may not be useful to me. But the blue dots represent how much Lightning McQueen moved on the y-axis. So if I move this back, so the blue dots here are not what's here. The blue dots on my graph, oops, undo, edit, undo VA point. I don't know why that happened. Okay, so what I just wanted to do was move to back. All right, so the red dots here on the graph, as you can see, unfortunately, because he went backwards, it goes backwards in time. So it goes from about 0.6 seconds to 0. Thanks for nothing. But if you arranged your video so that he started here and went that way, then these dots would be going in the other direction toward like that. All right. Hopefully that makes sense. Now, unfortunately, these are blue and these are blue, but they don't have a lot to do with each other. The blue dots here are just where the car was. The blue dots on the graph represent how much he's moving on the y-axis. So if you consider him moving, right, he started here on the y-axis and he ended here on the y-axis. So going up and down, he started here and he ended here. So he kind of moved a little bit on the y-axis because I didn't do a perfect straight line. That is not important for what we want to do, so we're going to get rid of that. So to get rid of that, we right-click Graph Options, and we get rid of the Y, because we don't care about how far he went on the Y. We really only care about his X speed. So let's move this to back now. So we only care about how long it took him to get from here to here on the X-axis. His Y motion was an unfortunate consequence of me not putting him in a straight line, which isn't important for what we're doing right now. We're just trying to get a good sense of what this does. So I'm going to move that to back. By the way, anytime I'm mostly right-clicking to have any of this happen. So he started at 0, and then in about whatever many seconds that is, about 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So each one of those is, what's that, 0.02? So it took him about 0.04 seconds to travel about 6 inches. So he traveled 6 inches. And if you look back on the graph, right? So in the first thing, he traveled actually about 3 inches. And then about 3 inches. And then about 3 inches. Yeah, he travels about 3 inches every time. Anyway, all right. We're just going to trust that this thing knows what it's doing. Anyway, all right. So, and over here, down here, you can see what is happening. So where my cursor is showing up down here. So I can put my cursor here, and that's 0.51 and 0.582 or 5.82. So that is up here, point number 7, right? And this one here is 0.468 and 9.10. So that's about point number 6. And this is point number 5, point number 4. All right. So the point of all this is, so this is tracking his distance traveled in inches. See, this is wrong. So this is saying he went about 25 inches. Let's see, go back to the, did he go 25 inches? Yeah, I guess he did. 20, 21, 22, 23. Yeah, about 20. The whole time he traveled about 25 inches, ballpark. All right, well, whatever. All right, so now what we can do is right click and do graph options. And there's two things. There's graph options here, and then there's axis options. So our axis options, I actually didn't want any of those. Time is the, yeah, this is all pretty good, I think. And here you can play around with this if you want to see, you know, if you want to change the scale here, you could change where things start. So that's interesting. So it starts at 0.24 seconds and goes to 0.56 seconds. That's interesting. So you can please play all you want with this, because you can always undo. You can undo right up here and just do edit, undo, whatever you just did. So what we need though is for this, we want a linear fit. And now that is a pretty nice line of what Lightning McQueen was doing. And here it'll show you what the slope was. So the slope represents the speed he was going. It's negative because he was going backwards. If the origin started here and he was traveling in that direction. So if instead of Lightning McQueen going from right to left on our screen right now, if he was going left to right, we would see that slope would have been positive. But since he was going left to right, right to left, it's a negative slope. But he was traveling 76 inches per second according to what we just graphed. And the b-intercept, so his y-intercept is not that important for what we're doing right now. We're basically just getting the speed and learning how this thing works. So feel free to play with this. To delete this, you can hit this little X here, and f of x is a curve fit. If we wanted to do a curve fit, you could choose different, you know, do we want it to be a linear fit or do we want it to be more of a quadratic fit? You will probably have to do something where you have more of a, what do you call them, where they look like a U, parabola, and you might want to do a quadratic fit or a cubic, or, you know, you probably know more about this stuff than I do. And then you can try it and see how it works. So here's linear, and it should give us the same thing that we just had. Yeah, so it's even a little more. So play around with this, but that is all I want you to do. And then you can save this file, save as, and then save it, and then email it to me or share it with me or whatever you want to do. And I'll give you credit for understanding that much about physics. I hope that's helpful. Please don't hesitate to talk to me about any questions you might have about this, but it's a good introduction to what you'll have to do in physics.